Now in this next problem we're going to find the tangent and normal lines of a trig function. Now notice we're looking at x equals 2, which isn't going to give us a very clean value here. So we're going to do this problem using our calculator. So we're going to solve the same as we would any other problem looking for the tangent normal line. We treat our derivative at that point as the slope of our tangent line, and we're also going to need to know the y value at that. So I'm going to start by putting this into my calculator. So I'm going to start by plugging in my formula, getting the tangent at 2 and dividing by 2. And that's going to give me my y value. And to put in my derivative, I could work out the derivative by hand, but I'm just going to use my calculator since I'm using it anyway. We're looking for the value, again, at 2. Our formula then is the tangent of 2 over 2. Or sorry, x. Make sure we're using the variable here. And that gives me 3.4364. So I'm going to plug these into my point slope formula. Notice I'm taking out y minus a negative 1.092. And I'm going to keep at least 3 decimals. Maybe I'll go a little bit more to make sure my final answer is accurate enough. My slope 3.4335, and then x minus 2. And that will simplify to this. Notice I've left 3 decimals there to give the accuracy that will be needed on the AP test. Next we're going to find the normal line, and to do that we just need to take the reciprocal of our slope. Again, we could use our calculator to do that. Just write 1 over that. And then we would plug in the same point that we used before. Our x is 2, our y is negative 1.0952. And that's what the book would give us, although it's not rounded to the required 3 decimal places. Trigonometric second derivative. So we want to find the second derivative of this. So our first derivative, we need to remember what the derivative of secant is. So the derivative of secant was secant x tan x. And so the second derivative of this, we're going to need to use the product rule here. The derivative of the first times the second plus the first times the derivative of the second. As we can simplify that, and we'll just leave our answer like that.